Hello, welcome to GES 100 at Cal State San Marcos. I'm Jerry Pinter, your instructor for the course. I'd like to take this opportunity to reach out and personally welcome you to my class. I sure wish I could be in the classroom with you right now and get to meet you face to face and in person, but under these circumstances, we'll just have to make do with remote learning. So here I am, floating around in space, hoping that this message reaches you. Please sit back and enjoy this first video lecture where I'll try to introduce and let you know everything you need to know and do and introduce the course so that you can succeed in GES 100. Don't hesitate to reach out and contact me if you have any questions or concerns or just want to chat and say hi. My contact info will be given in the video. Thank you. Hello, welcome to GES 100, the physical science around us. This is your instructor, Mr. Jerry Pinter. I'm disappointed that I won't get to meet you in person in the classroom. However, I'm still looking forward to teaching this course online this semester. I hope that you'll enjoy my class and learn a lot about science. I have designed this online version of GES 100 to include all of the material, content, examples, demonstrations, and experiments that I would normally do in the classroom. I personally guarantee that you're not going to miss out on anything just because this class is online. In this video, I will introduce our course and explain how you will take the course and provide you with all the detailed information you need to succeed in this class. Let's get started. Let me start by introducing myself in a little more detail. As I said, my name is Mr. Jerry Pinter. And my background is electrical engineering. I spent 17 years working in the industry in local companies here in San Diego. I was fortunate to be able to retire early back in 2002, and since then I've been at Cal State San Marcos teaching physics, astronomy, and electrical engineering part-time. I'm also married and have 2 kids, and my son is currently a student at Cal State San Marcos. I think the best way to introduce this class to you is just to go through some of the most important parts of the syllabus. So in the next few slides, that's what I'm going to do. So our first piece of information here is, of course, we're going to be using Cougar courses to store a lot of the information. I'm assuming that you are familiar with Cougar courses and have already accessed it, but if you're not, it's at www.csusm.edu. The important thing for our Cougar courses is all the lecture notes will be posted there, and also this full syllabus will be posted on there as well. So make sure you're familiar with our Cougar course for our GES 100 class. I will be going through this homework and quiz details in more detail in a couple slides. But for now, this is something important. You're going to need to go to this website, masteringphysics.com, and that's where you're going to do all of the online homework and take all of the online quizzes. So I'll be explaining this in more detail shortly. Also, our lectures, because this is an asynchronous online course, you're going to be watching lectures on YouTube. And so I have a YouTube channel for our class. It's called CSUSM GES 100, and I will also later in this video explain how to access all of the lectures for this course. So my name again is Mr. Jerry Pinter, and office hours, we'll see what works best for you guys, but most of the time, probably 99% of the time, if students have questions, they can just email me, and I will get back to you within 24 hours. So that's probably the best way to handle most of the questions that you might have about, for example, homework problems that you couldn't do, or if you're confused about some of the material in the lectures, or if you just have a question about the course in general, just send me an email. My email is right here, jpinter@csusm.edu. And if we have to, if we can meet face-to-face by a Zoom meeting, if that's necessary, but that's usually not the case or necessary for this type of course. Okay, so let's talk about the textbook. The textbook is called Conceptual Physical Science, and technically we are on the 6th edition. The authors are Hewitt and Suchaki. Now, this textbook is, if you're going to go out and buy it brand new, it's going to be very expensive. It's going to cost you, close to $200. There are some other options that I would recommend. One option is you can get the Mastering Physics Access Code, which you absolutely have to get, and that can come with an ebook. And you can get all that, bundled together for about $95. You can purchase that online at this website up here, masteringphysics.com. What I recommend to save even more money is to do this. Go to this website, masteringphysics.com, and I'll provide more details on how to do this, but it's pretty straightforward. And set up your account and buy the access code by itself. And it's about $65, okay? And this access code will allow you to do the homework and the quizzes. So that's something that you absolutely have to get. Now, regarding the textbook, my recommendation here is to save some money, get an older edition copy, a used older edition of the textbook. For example, the 3rd edition or the 4th edition of the textbook are just fine. And I've seen them on Amazon for as little as $5 or maybe $8. So that's a pretty good deal. So if you do the access code for $65 and pick up a cheap textbook for less than $10, that's a pretty reasonable and economical way to take this class. So just a brief course description here of what we're going to be studying, and I'll talk about this in a little more details later. But this is an online and asynchronous course, and if you don't know what that means yet, don't worry about it. I will explain this later. But we are going to be introducing some of the basic concepts and ideas of physical science. And also, we're going to be talking about astronomy. So basically, we're going to be learning about topics from physics and astronomy in this course. So it'll be a very broad range of topics that you're going to learn, and I hope that you find a lot of them interesting, and I will almost guarantee you that you're going to learn quite a bit in this course. There will be math involved with some of these subjects, most of them actually, but not all, but the focus will be on conceptual understanding whenever we can. So regarding our course grading, the course is very simple in this context because there are really only 2 things that will determine your grade. Half of your grade will come from your homework, and this is done online, and there's a total of 13 assignments, and I will give you more details on homework shortly. The other half of your grade comes from quizzes, and you will be taking 13 quizzes. For each of these homework assignments, there will be a quiz that you will follow up with. And so between the homework and the quiz, that is your grade. So the good news is there are no midterm exams in this course, and there is no final exam in this course. So I think you'll appreciate that. You don't have to prepare, for big exams or final exams. But, on the downside, you will be taking quite a few quizzes in place of those bigger exams. The grading scale right now is just set to pretty much a standard scale. An A will be earned if you get 90% or more, on the homework and quizzes, and a B 80%, and a C is 65%. Now these are not firm. I may lower these requirements somewhat. In other words, I may curve these numbers depending on the distribution of quiz and homework scores, but that probably won't be evident until near the end of the semester. But you can be guaranteed if you get these scores here, you'll earn at least this good of a grade and possibly better. Oh, by the way, up here I didn't mention there is an opportunity to get some extra credit. You can look at Cougar courses and read about the extra credit there, but it turns out to be 6% availability, so that's a nice boost to your grades. So let's talk now a little bit in some detail about what you're actually going to have to be doing online to do well in this course. Basically, it boils down to there are three things that you're going to be doing. You're going to be watching lectures, video lectures. You're going to be doing homework online, and you're going to be taking quizzes online. So in general, you'll basically watch a lecture, do the homework, and then take a quiz, and then move on to the next chapter. And I'll talk about a little more detail on the topics and schedule a little bit later. But for now, let me talk about the online YouTube video lectures. So this course is asynchronous, which means you can watch the pre-recorded video lectures for each chapter at any time of the day or night at your convenience, and you can watch it as many times as you want. So you're not going to be logging into a Zoom session and watching a lecture live. You don't have to be, watching the lecture at any given time of the day. It's completely up to you. The lectures are pre-recorded and they are posted on YouTube so that you can watch them whenever you want and however many times as you want. You can watch them over and over, or you can stop the lecture and go back if you missed something, etc. And again, these video lectures that are posted on YouTube contain the exact same material, content, examples, demonstrations, and experiments that I would use in the classroom. So you're not missing out on anything by doing these lectures online. The only difference is you won't see me up in front of the screen, like you would in the classroom, but you're going to hear my voice, you're going to see me pointing out things with a pointer on the same notes, and also you'll see experiments and demonstrations that I do, which I would normally do in class live. I've got them all videotaped so you can watch them, and they're all built into the lectures. So the lecture notes are also available and are posted on Cougar Courses. So these lecture notes are PowerPoint slides only. They don't have my narration or video demonstrations. So you're going to use these for review only. So always you'll start by watching the YouTube video lectures, and then later on, if you want to go back and review the lecture, you can either watch the YouTube lecture again, or you can go to Cougar Courses and pull up the PowerPoint lecture notes and see the same slides, but I won't be explaining them. You'll just have to, look at the content yourself. But it's there for your convenience to help you review and summarize the chapters, etc. Being asynchronous, there is no attendance or mandatory participation. So in other words, I don't know, I won't know if you're watching the lectures or not. It's completely up to you to watch the lectures, take notes on the lectures, etc., and prepare yourself so that you can do well on the homework assignment, and then in particular on the quiz that is associated with that lecture and homework assignment. So this is, sort of an honor system. It's obviously in your best interest to watch these lectures and watch them carefully, just as if you were in the classroom. Pay attention, take notes if you need to. All the information and content is there, and my explanations, just like you were in class. Hopefully it will feel like you're sitting in a classroom with me talking and explaining and lecturing and showing information. So you'll get a sense for those later when you start seeing the actual lectures. Now, the class is asynchronous. However, we have to be careful here. The homeworks and the quizzes have due dates. Okay, so be sure to keep up and watch the video lectures for each chapter before the due dates so that you can finish the homework and quizzes on time. So in other words, just because it's asynchronous doesn't mean that you can just put everything off. You will typically, once we get going, every week you'll be watching video lectures, you'll be finishing the homework, and you'll be taking a quiz pretty much every week, and you'll have to do that. So you have to make sure that you finish the homework and the quiz by that due date, or else you'll get a pretty stiff late penalty, and you don't want to do that. You want to get all the points that you can.
So where are these video lectures? Well, the video lectures are found on my public YouTube channel, which is called CSUSM GES 100. So on the next slide, I will explain how you can access these video lectures and get started. So the information on this page here is very important. This is how you're going to access, find, and watch the online YouTube video lectures. So step one is go to YouTube's webpage at www.youtube.com. And YouTube has, when the page comes up, there will be a search bar at the top of the YouTube page. So you're going to enter CSUSM space GES space 100. And after you do that, you'll see the following icon at the top of a list of videos. So a bunch of videos may show up, but way at the top, you're going to see this blue circle with a C in it. And it should say CSUSM GES 100. This is the icon for our YouTube channel for our class. So you're going to click on this icon, and that will allow you to enter the channel. So now, after you do that, you should see this at the top of the page. It should say, again, you should see our icon. It should say CSUSM GES 100, and you'll see some options here: home, videos, playlists, channels, etc. So you're going to click on the videos tab right here. So just click on that with your mouse. And after you do that, you're going to see all the videos for our class. And a warning here, there are a lot of them. There are almost 40 of them because many of the chapters I split up into parts. And that'll become more clear later, okay? But yes, you are going to be watching all of these videos before the end of the semester. So to get you started, what you can do is scroll to the bottom of the list and find Chapter 2, The Language of Science. I apologize that the videos are listed sort of in reverse order. The first videos that you're going to watch are generally going to be down at the bottom. So this is our first lecture. We're starting with Chapter 2 in the book, and it's called The Language of Science. And so you can click on that video and you can watch it anytime. Remember, this is an asynchronous class, so you can watch the video at your convenience. Now, as I mentioned, some of the chapter videos are broken into several parts due to the length of the video. So our first video on Chapter 2 is not that long. It's maybe 30 or 40 minutes, so it's all just one video. But for example, the next chapter, Chapter 3 on motion, because it has so much material in it, I split it up into 4 parts. So there's Chapter 3 Part 1, Chapter 3 Part 2, Chapter 3 Part 3, and Chapter 3 Part 4. So be sure to watch all parts of each video before doing the homework and quiz for that chapter. Otherwise, you're going to miss out on some of the lecture, and you're going to have no idea how to do the homework, and you'll do poorly on the quiz. Okay, so just, and watch the parts in order. Obviously, you watch Part 1 first, and then Part 2, Part 3, and Part 4, etc. As I mentioned, these lecture notes are also posted on Cougar Courses without the video animations and without my voice narrating. So those can be useful for review, but don't rely on those Cougar Course lecture notes until you've seen the videos first. So be sure to watch the video lectures so that you get the whole picture, with all of my explanation, and all. I'm going to be doing demonstrations that are done, were video recorded and so forth, and those won't be on the Cougar Course versions.
So let's say you've watched the first video lecture and now you're ready to do the homework. So how do you do this? Well, all of our homework and quizzes will be done and graded completely and automatically online using Mastering Physics, which is an online homework platform that basically comes with the textbook. So what you have to do is first purchase the access code that either comes with a textbook, or as I recommend it, buy it separately. Just buy the code by itself, which is about $65. You can buy it online at this website here. And once you set up your account, you have to do this, the first time you log in, It's going to ask you to set up an account. You can give it a username, you can give it a password, and so forth. And then after that account is set up, you're going to just log into this website here, masteringphysics.com, and you'll see all of our homework assignments and all of the quizzes and so forth with the due dates. And that's where you're going to be doing all of your work in this class. Okay, so after you watch an online video lecture, you'll be ready to do the homework. So when you first set up your account at masteringphysics.com, it will ask you if your instructor gave you a course ID, and tell them yes, and the course ID is Pinter 68852. So you'll just enter that and you should see our course, GES 100, and then just follow the rest of the instructions. Have your credit card ready and buy that access code, and you're set to go. So how do you do the homework? Well, again, make sure you watch the YouTube video lecture for the chapter before you attempt the homework. So the video will have all of the background material that you need to do the homework, and it'll also, of course, show you examples of how to do, some of the homework type problems. I've set up the homework so that you can succeed and do very well in it. In fact, I've set it up so that you'll get 10 attempts to answer numerical questions. All right, so that means you can keep trying until you finally get it right. And I've done this intentionally so that you can feel like you're getting confidence and accomplishing a lot by doing the homework and getting a really good homework score, because that's the way you're going to learn this material, and that's the way you're going to be able to prepare for the quizzes. Okay, so the homework shouldn't be super stressful because you got all those attempts to answer each question. And of course, if you're stuck on a question, you can email me for help, as long as it's not right at the last minute before the due date. I will get back to you most likely later in the day or the next day and show you how to do that particular problem that you might be struggling with. Homework and quizzes, of course, have due dates, and if you don't submit something by the due date, you will be penalized for each day that it's late, up to 50% max. But this does mean that if you do miss a homework assignment because something came up or whatever, it's not the end of the world. You can still submit it late for partial credit. So that's obviously much better than getting 0%. The other thing I should just mention here is don't wait until the last hour before the due date to do your homework, because if the website, the Mastering Physics website crashes, that's not my problem. There's nothing I can do about that. This website belongs to the textbook, Pearson.com, and so I can't help you if there's a technical problem. You're going to have to take a late penalty. Okay, so don't wait till the last minute to do your homework. You may have an internet connection problem, or your computer might have an issue or something like that, and it's a shame to miss those points. So get the homework done early. Start working on it several days before the due date if you can. So after you have watched the YouTube video lecture, and after you do the Mastering Physics homework assignment, you're ready to take the quiz, or at least ready to start preparing to take the quiz for that chapter. So the quiz, there will be a quiz for each homework assignment, and it's based on the same material as the homework. So you can think of the homework as just a way to practice for the quiz. So I want to go through some of the next couple of slides, some of the important information about the quizzes. So the quiz is to be taken by yourself without any help from friends, classmates, tutors, websites, etc. This is all honor system. You're not going to be taking the quiz proctored on Zoom or monitored on a camera or anything like that, but it is honor system. You're to do the quizzes by yourself. The quizzes are timed, so this is the tricky part. Unlike the homework where you have basically days or weeks to finish it, once you start a quiz, you have 30 minutes to finish the quiz, and the quizzes are worth 10 points each. They're usually 10 questions. Sometimes there are fewer questions that may have several parts, so some questions are worth more than 1 point. Now, these quizzes are asynchronous, meaning that you can start the quiz at any time or day as long as it's before the due date. So this is a nice thing, obviously, about this type of class, is that you can schedule the quiz around your work and school and social schedule, etc. You don't have to log in at a specific time as long as you do it before the due date. But remember that once you start a quiz, you have to finish it, and you'll have 30 minutes. Each quiz must be completed before the due date at midnight. Due dates are posted on Mastering Physics, and they are also shown in a table a couple slides later, which I will be going over in detail to make sure there's no confusion on this. The quizzes are open notes, so you can prepare your notes, and it's open book too. You can have the book there. So you know that you can prepare notes based on lectures and homework that will help you with the quiz. So you know you can think of making sort of a study guide or a cheat sheet, if you want to call it that, for the quiz. Put all your equations on there, any methods that we discussed on how to do problems. You can put examples on there, definitions, and maybe even some of the homework problems that you might have struggled with. So these are all good things to have right with you while you take the quiz, so that you don't have to you know, try to memorize too many things here, but you will have to know how to do these types of problems. Let's see, also the quiz will not let you access other websites while you're taking the quiz. So be sure you have your notes available, you know, written or printed out or something like that. I wouldn't rely on them, having them on your computer, because you may not be able to leave the site of the quiz. Here's some more information on taking the quizzes. After you do each problem, be sure to hit the submit button, you know, before you go on to the next question, or else it may not record your answer. So, you know, this will become more apparent once you start doing homework and quizzes on Mastering Physics. Most of the quizzes cover a single chapter, the same chapter that is covered in the homework for that chapter. And the homework assignments and the quizzes are numbered 1 through 13. We'll go over this in more detail when we go over the table on the next slide. One thing though, I'll warn you, is that the chapter numbers don't always match the homework or quiz numbers, because we're going to be skipping around the textbook, and in fact some of the material that we're going to be covering in this class is not even in the textbook. You're just going to be using my lectures and lecture notes. And then, you know, we'll see this in the table in the next slide. Some of the homework assignments and quizzes cover more than one chapter. So we'll go over all the details of this, and this will be more clear on the next slide. Let's see, you won't see your quiz results, or, you know, your grade until after the due date, I believe. And this is just one of the, you know, the things about the Mastering Physics system. I have no control over this. So in other words, when you finish your quiz, you may not see your score right away. You may have to wait until the due date. And you'll never be able to review your quiz or see which questions you got right or wrong. That's just part of the online nature of this course. So once you do a quiz, it's basically, you know, it's gone forever. The only thing that remains is your score on it. I have the ability to go back and review your quiz, but you won't be able to see those questions again. So what's the best way to prepare for these quizzes? Well, you know, obviously first, watch the YouTube video lecture. Watch it very carefully. After, you know, while you're watching the lecture, you can pause it. You can go back and rewind, you know, and re-look at a part that didn't make sense to you and so forth. So make sure the lecture is sinking in when you watch the lecture. And then, of course, you're going to do the homework assignment first, and that will help you prepare for the quiz. So make sure you know how to do all the homework questions and understand them. You know, especially if you've got some help on the homework, if you asked a tutor or another classmate or something like that, you know, make sure you know how to do those problems on your own, so that when you get to the quiz, you won't have any issues there. And, you know, take notes on anything you can't remember or have difficulty with. Remember, you can use these notes to help you during the quiz. The quizzes are open notes. So this is probably the most important slide in this whole first lecture, because this single chart here, our table, has all of the lecture homework and quizzes on it that you're going to do for the whole semester. And even more importantly, it has the due dates when you have to do them by. So, again, just to remind you, this course is asynchronous, and that means that you can watch the lectures and do the homework and take the quizzes at any time of the day or night, as long as it's before the due date. So this provides you and offers you a lot of flexibility in managing the course. You can take it sort of at your own pace, but obviously you're going to have to keep up with the due dates. So what I'd like to do is go through some of this table in detail, because you're going to be referencing this table. This would be a good thing to maybe print out. It's in the syllabus, and this is kind of how you're going to work through this course. So what this table shows here is, on the left column, there are book chapters that align with the assignments and the lectures. Now, not all of the material that we're covering is in the book. So you'll notice the first couple of items here, there is no chapter associated with it. Okay, so you're just going to watch my lecture and learn the material from that. This second column here is the YouTube video lecture topic. So this is what you're going to actually be studying, the topics. Okay, and we'll go through some of these shortly. And then this column here shows the homework numbers. Okay, so the homeworks are, they start actually with homework 0, which is a practice homework, and it goes up through homework 13. And the quizzes are shown in this column here. The quizzes go from 1 through 13 and match the homework numbers. And then, most importantly, these are the due dates over here. And remember, for the homework, these due dates are firm, but you can always turn in homework late with a penalty. However, for quizzes, you will not have that option. So I repeat, if you miss a quiz due date, you have blown it, right? You're going to get a 0 for that quiz. So please do the quizzes well before this due date so that you don't run into any trouble there. So let me show you how this works. The first thing you're going to do once you set up your Mastering Physics account is, there's actually no video for this, but you're going to do homework. It's called homework 0. And homework 0 is just a practice assignment to teach you how to use Mastering Physics. So it'll tell you how to basically enter numbers such as scientific notation. It'll tell you how to enter exponents, square roots, things like that. So I would definitely do this assignment, but it's not graded or anything like that. It's just to teach you how to use the system. So that's something you can start working on immediately. There is no quiz for this homework assignment because it's just, for practice, okay? So here's where we're actually going to start. The first real lecture of the course is called The Language of Science. And this is something that's not actually in the textbook. This is just an introduction to some of the math and some of the units and scientific notation that we're going to be using in this course. So all the material that you need is in the YouTube video lecture called The Language of Science. And you'll find all of these videos, again, are on our YouTube channel. Once you watch this, you can start working on homework number 1, which will cover this material. And then after you do that, you can take quiz number 1. And notice that these are not due until September 19th. Now, the reason I pushed the due date out a few weeks is because we're going to have some students who are going to be dropping and adding the class. So they're going to be coming into the class late. Also, some of you might be waiting for financial aid before you can buy your textbook or your access code, and so forth. So while you're, this is something that you can be working on during the first week of class, I would actually recommend that. But notice you have a little cushion there on the due date, okay? So then after you do that one, you're going to, the next topic is on motion, moving objects basically. And notice there are 4 videos here, 4 parts. So there's motion part 1, part 2, part 3, and part 4. So these are 4 separate YouTube videos that you're going to need to watch, all right? And this material comes from chapter 1 in the textbook. So after you do watch all of those videos, you're going to start homework number 2. And after you do homework number 2, you can prepare to take quiz number 2. Now notice that homework 2 and quiz 2 are due on September 20th, which is just one day after homework 1 and quiz 1. So again, don't wait until September 19th to do this first assignment, all right? Do it during the first week of class. Stay ahead here because the first, 3 chapters are due basically during the first 3 weeks of class. And then, basically what you're going to do is you're going to just keep working through this table. After you do, the part on motion here, our next topic is forces and Newton's laws. Again, notice there are 4 videos here, parts 1, 2, 3, and 4. So watch all of those. This goes with chapter 2 in the textbook, so you can use the textbook here to supplement the video lectures. And then you can start working on homework number 3 and take quiz 3 all before September 27th. Okay, and then you're just going to keep repeating this process. You're going to watch video, do a homework, take a quiz by the due date. The only other couple of things I want to point out here is, let's see, for chapter 10, actually there are 3 videos, oscillations and waves, parts 1 and 2, and sound. This is all homework 7 and quiz 7, which is due October 25th. And also down here, you'll notice that chapter 21 and 26, they are bundled together and they're both covered in homework 10 and quiz 10. So in this case, one homework assignment covers 2 chapters in the textbook. Okay, so that's sometimes the case in this class. Then here's the next thing I want to mention is the last roughly 5 weeks of the class, the last 1/3 of our course, we're going to switch gears and you're going to get an introduction to astronomy. And so these chapters, some of this material is in the book, but not all of it. So I put the chapter numbers in parentheses there from the book, but basically you're going to be using my lecture notes, which are labeled A, B, C, D, and E. And so, once we get to that part of the course, I'll remind you about this. But again, this is all of this stuff is on YouTube, and you'll be doing quizzes here. Homework and taking quizzes on that material as well. Finally, just want to mention one more time. Remember, there are no midterm exams and no final exam for this course. So obviously, that is a nice thing. You'll have to do, obviously, 13 homeworks and take 13 quizzes, but that material there, the homework and the quiz, that will constitute your grade for the class. No exams and no final. So that's great news.
So now that we've covered sort of the nuts and bolts and business of the course and what you're going to be doing and how you're going to access the lectures and the homework and the quizzes, let's now kind of change gears here and let me just do sort of a brief introduction to the actual content of the course, and that'll conclude this video. So the next few slides I want to hopefully give you a little introduction to what is science and some of the things that we're going to be talking about in this course. So the first question here, what is science? Obviously this is a science class that you're taking, General Education Science 100. Science can sort of be summarized into 2 different things. The first thing is science is a body of knowledge that explains the natural universe. So this is, includes scientific facts, like things as obvious like the Earth is round, things more complicated like the structure of the DNA molecule. That's scientific knowledge that we already have. Water is a molecule given by the chemical symbol H2O, or Einstein's famous formula E = mc². explains the relationship or the equivalency of energy and mass. So these are scientific equations or formulas here. So this stuff, this is stuff that's already known and it's in textbooks. And basically in our course, this is what we're going to be working on. We're going to be talking about this vast body of knowledge, and we're going to pick, certain topics out of this and cover this in our course. But science, of course, is more than this. More importantly, really, science is a method and a process of seeking this knowledge. And the purpose of it is to understand the natural world that we live in. So science is based on gathering and examining and interpreting evidence, doing research and experimentation, and the goal is typically to develop new theories that explain things about our world that we live in. For the first 2/3 of this course, we're going to be dealing with selected topics in physics. So what is physics? Well, physics is a description of nature based on relationships and interactions between matter, motion, and energy. And physics is the most fundamental science. All of the other sciences, in some way, shape, or form, connect back ultimately to physics. So physics includes lots of topics, and some of these we're going to be talking about in this course, and others we won't. But for example, in physics, the term mechanics refers to motion, forces, momentum, work, and energy. Most of this stuff we're going to be talking about in this course. Thermodynamics is the fancy term for heat, temperature, thermal energy, and so forth. We will be talking about this in our course as well. Physics includes electricity and magnetism. We will be covering electricity in this course, but not magnetism. Physics includes the study of optics, which is the study of light, and we will be looking at the study of light in some detail in this course. There are other branches of physics, such as astrophysics, and we are going to be touching probably not as much on astrophysics, but we will be covering astronomy later in the course. And one thing we will be talking about in our class is atomic physics and nuclear physics. We will be talking about the atom and the nucleus of the atom. And then there are other branches of physics that we won't be talking about in this class, such as quantum physics, the theory of relativity, solid-state physics, subatomic particle physics, biophysics, and the list goes on and on. So physics is a very, very broad and also very fundamental science. So at this stage, you might be wondering, well, I'm not a science major, so why should I have to study physics and astronomy? Well, that's a good question, but it's an important question to address right away. The reason it's important that you study stuff like this is to have a general understanding of the physical universe that we live in. In particular, we live in an era where there's tremendous technology and science all around us. We just take it for granted every time we pick up a phone, a smartphone, or drive in a car, or fly in an airplane, or watch television. This is all technology at work. And so the world we live in is a technological world. So it makes sense to try to gain some understanding of it. And also the natural world around us, even if it's not technological in nature, if you think about looking up at the night sky and ever wondered, what you're seeing, what are these stars out there, and so forth. Well, those are the types of things that we're going to address in this course. Another one which is kind of interesting and actually very personal, is the idea of our origins. We're going to learn where we came from and how we got here. And the other sort of important thing here is to learn how modern science is based on evidence. And this hopefully will become very apparent after taking this course, and you'll have a good appreciation for what science can do and how powerful it is, and how it's our best way of basically reaching and learning about the truth. Also, maybe on a more personal levels, and that something will help you, is that by studying science like this, you're going to develop methods of problem solving, rational thought, and critical thinking that apply to your academic, professional, and personal lives. You've probably heard of the scientific method, and I would bet that you've seen this before, since this is taught in not only in high school, but it's even taught in middle schools now. And so the scientific method is important because it's not only used by scientists, but it's a very good problem-solving approach that you can use for lots of different areas of your life. So there are different ways to formulate or list the scientific method. This is a common one that I'm going to show you here, and we'll work through an example just so you can kind of get a sense for how to use this. And you'll probably also find out that oftentimes you may be using something similar to the scientific method to solve problems. So the first step here is to observe and make a problem statement. So, this could be something complicated, like, a scientist is looking through a telescope and sees something, that is not explainable up there in space, right? Or it might be something as mundane as you go out, to start up your car, and you turn the key and your car doesn't start. So now you've basically come up with a problem statement. My car doesn't start. So the next step is to make a hypothesis or an educated guess. Why do you think your car doesn't start? Well, there are multiple reasons why your car might not start. So let's take one hypothesis. Maybe the first thing you would assume is that your battery is dead. So after that, you make a prediction and predict the consequences if your hypothesis is true. So what you do here is you say, all right, if this is true, if my battery is dead, then other electrical systems in my car shouldn't work. For example, my radio shouldn't work and my lights shouldn't turn on. So that is my prediction. If my battery is dead, then my radio and my lights will not work in my car. So the next step, of course, is key. This is where you test the hypothesis with experiments. And this is sort of an interplay between evidence and hypothesis. And this is really the crux of what science is all about. So how do you test your radio and your lights? Well, very simple. You just try to turn them on, right? You turn on your radio and you listen. Does it work? You turn on your lights. Maybe you have to go outside your car and look at your lights to see if they're on. So based on the results of this test, then you can come up and make a conclusion. So if your radio and your lights don't work, you can probably accept your hypothesis and assume correctly that your battery is dead. However, if your radio and your lights do work, then you have to reject your hypothesis. Your hypothesis was incorrect. And it's not like you've wasted time, because what you've done is you've eliminated one of the possible causes of the problem. And so even though we come up with a rejected hypothesis, that is not necessarily a bad thing. And so in that case, you'll have to repeat this process and keep repeating it over and over until you finally get to the answer that you're looking for, which is to find the reason that your car doesn't start. Let's go over a few scientific terms that we'll encounter these throughout the course when we're going through the lectures. And some of these are pretty obvious, but other ones are sometimes misunderstood. So the first one, we already saw this on the last slide. This is scientific hypothesis. A hypothesis is an educated guess or an assertion that's not yet tested or validated. In other words, a hypothesis may be true or it may be false. So for example, if I state that all Californians love the beach, well, this is a hypothesis, and how would I test this? Well, I'd have to take a survey, right? I would have to ask people on the street, do you love the beach? And I'm probably guessing that soon enough I'm going to find somebody that doesn't love the beach, and in that case this hypothesis would be false. Now, a scientific model is a conceptual description of how something in nature works. Models are often intentionally simplified from reality in order to allow ease of understanding and use. So we're going to use scientific models throughout this course because the models are typically much simpler than the way it actually is. So one example is the model of an atom, which we will talk about later in the course, where we have this nucleus in the center and we have electrons in these orbits or energy shells around the nucleus. And that's not really completely the way an atom works and is. However, it is a very successful model that explains a lot of the properties and characteristics of an atom, and that's what makes it a successful model. So some models are better than others. A scientific fact is an observation that is repeatedly confirmed by evidence. So for example, all protons have the same mass. Well, this is true. Every proton that has ever been measured by a physicist has precisely the same mass. In a sense, every proton is identical to each other. So this is just taken as a fact. A law, a scientific law, is a description of natural behavior that is consistent with evidence. We'll learn about lots of laws in this class. For example, Newton's second law of motion, which is sometimes stated F equals ma. This is a relationship between force, mass, m, and acceleration, a. And so objects behave according to Newton's law. So this describes the behavior of how an object accelerates when we push something, when we apply a force to it. Okay, so that's what we mean by a law, a description of how something behaves. A scientific theory is different. A scientific theory is a system of rules and principles to explain something in nature that has been tested and is supported by all available evidence. So there's two key things here. What a theory is in science is not a guess. Remember, that's a hypothesis. A theory is an explanation of something. And furthermore, and this is important, a theory has been tested and is supported by all available physical evidence. So a theory then is the highest level of confidence that we can possibly have in scientific understanding. So for example, let's take gravity, right? Something that you're certainly familiar with. If you jump off of a chair, you end up on the floor. Why? Because of gravity. So gravity is a fact, and it's also, there is a law due to Isaac Newton that describes the way gravity behaves, and gravity is a theory which is explained by Albert Einstein. Okay, so gravity being a theory tells you that a theory is not just a guess. Okay, this is the theory here, explains how gravity works. There is something called quantum theory, which is used to make and design all of the modern electronics that we take advantage of today in our smartphones, in our televisions, and in our computers. It's based on quantum theory. Darwin's theory of evolution by natural selection is considered to be one of the greatest explanations and scientific theories that exist. So the main thing about, especially the bottom part of the slide here, is that when you hear somebody say, well, it's just a theory, that's sort of an oxymoron. That's an inaccurate statement. A lot of people use the word theory sort of in everyday life. They use it instead of hypothesis. But when scientists say something is a theory, we are talking about this definition here, which is our highest level of confidence and understanding, such as the theory of gravity. So here's our last slide for today's introduction and lecture. We can think of science as a tremendous achievement. In a way, it's a triumph of human intellect. Our ancestors viewed the universe as this awesome, mysterious, fearsome, and completely incomprehensible and non-understandable entity. They could only explain nature in philosophical and religious or supernatural ways. For example, lightning used to be thought to be caused by angry gods. Also, there are hundreds of creation myths throughout history and cultures. Every religious sect, every tribe, every civilization has had their own creation mythology to try to explain where the earth and where humans came from. Modern science, on the other hand, has allowed us to explain nature using evidence, observation, and experimentation. So this is a new and different way of looking at the world around us. From this, we now have a much clearer understanding of nature and our place in it. For example, the universal laws of physics that govern the universe, the history of the universe from the Big Bang to the present day, the origin of our Earth, the Sun, and our solar system, and amazingly, we now understand the evolution of life on Earth from simple species to complex ones like ourselves. So we still see nature as this awesome machinery, and there are many mysteries that remain. Future generations will hopefully fill in these gaps of knowledge. So that, my friends, is our introduction to the course. Remember to check out on Cougar Courses, go to the syllabus, and you can see details there. But the next step for you is to set up your Wiley Plus account, and also make sure you can find the video lectures on YouTube, including the first content lecture, which is Chapter 2, The Language of Science. Until then, I will see you there. Goodbye.